This same thing. Same thing.
Freeing Sisyphus declaratively addressing web security issues. Lucas heads up the security team in Mozilla, herds bugs, and tries hard to make the internet a happier and safer place. Previously, Lucas was a security architect at Adobe, focused on Flash Player and Air. He also worked at AdStick and developed security managed services software at Breakwater Security.
So thank you for coming. I was very inspired by the sort of very positive and uplifting keynotes we had this morning. They really made me very optimistic. So in that vein, I think this is kind of continuing in that happy sort of groove. So you go to security conferences, a lot of fear, a lot of frustration. This is kind of understandable. You hear sort of perception of we are doomed. I can't really argue that one, so we're just going to move on. Endless parade of cross-site scripting, CSRF, overflows. Nothing's been done about it. And that perception is pretty understandable. And if you've been to these conferences for years and years and you're seeing your 27th cross-site scripting talk, it gets a little frustrating. Users are clueless. The sort of frustration of users are really not getting it. Users are not getting better about security, and trying to train users to make the right decisions is seeming to be a sort of never-ending battle. And also, the sort of dumbing down of security relates to the previous topic that we're basically giving up on users, right? We're saying, look, they're just not qualified to make decisions, so we're going to take decisions away, which is frustrating people that are very skilled in security. They want to have the information, they'll make the decisions based on that information, right? So what does fear lead to? I know this is not Star Wars. Unfortunately, in this case, fear leads to loathing. Loathing of standards and security, the perception that the standards plus security equals broken, that standards aren't really addressing security effectively, and people are pushing weird stuff out there, and then we have to all go clean up the mess. That software vendors are not cooperating, not discussing these problems, and also going off and developing their own one-off solutions that may or may not actually work, but are almost certainly not interoperable with everybody else's security model, right? Users never learn. That's possible, right? I'm not actually ruling that just simply may be the case. Functionality and complexity increasing. This is actually a big problem, right? Like if you look at the security model of browsers becoming more complex, and this is because browsers sort of got stagnant, right? There's this weird thing when the .com happened and everybody got more complicated and there was all this competition and people built great stuff, except in the browser, where nothing happened for like 5 years. And when you sort of Firefox sort of re-enter the market, it fired off a competition. You have, Safari, you have Chrome, you still have Opera out there. You have a lot of people. It's sort of like the .com again, in the sense that like there's all this rapid innovation, and the model is changing, becoming more complex year after year. On top of it, the current model is changing underneath you, where if you test some exploit against a version, an update comes out and you got to retest everything again, because whatever your presentation contains may no longer be accurate vis-a-vis the latest update of a given security package, right? And this rate of change is accelerating, right? We're seeing more and more innovation. If you're looking at, if you've been following the W3C spec process, a ton of stuff in HTML5, there's cross-domain loading mechanisms. There's talk of, there's like 3D rendering. You could deliver potentially a shader to a browser and have it execute and have like a rich 3D environment inside a browser. Really interesting stuff and scary. So standards and security, there's a couple problems here. One is the security community isn't really participating, right? The security community often behaves as a consumer of these standards rather than an active participant in these standards. And that's neither productive nor really necessary, right? These things are fairly open, and I would encourage everybody to go take a look at W3C mailing lists and the specs are out there and participate and comment in them, right? Because that's how you get the change that you want before it just gets finalized and implemented and everybody has to live with it. Politicized. Vendor competition can limit the potential solutions, right? And this is not really as nefarious as it seems. This is simply, unfortunately, the fact that every company has agenda, everything they want to do. In some cases, what actually happens is that there are small organizations that participate in the standardization process with the goal of getting their pet feature in there, right? And you can have these discussions getting derailed by the fact that somebody just really desperately wants something in the specs, so that way everybody implements it and they can go do something. Patent law is becoming a serious problem here too. There's a lot of fear of what they call submarine patents, where an organization will actually try to standardize something knowing they have a patent that they haven't really talked about, haven't made public yet, with the hope it gets standardized, everybody implements, and suddenly, hey, they whip out the patent and now you're in trouble, right? So there's a lot of angst, and the process is not as functional as it really ought to be. But I think it is improving slowly. And some things really aren't well suited to standards. Like trying to standardize UI, we've had these discussions a couple times with different standards bodies, and the idea of having a way of dictating how UI should work is a wonderful concept in theory, but the reality is nobody, trust me, nobody wants to use a UI designed by a committee. If you have a UI that's designed by a bunch of different working groups that dictate you have to have this icon here and this icon there and this wording has to be yellow and a font size X or Y, it's going to suck. You're not going to use the product. So there are limitations of what you can even try to standardize effectively in terms of security and UI. Next. Yes. Complexity is increasing. I've noticed this trend a couple times talking to researchers that, when I worked at Adobe, and now that they go do a presentation about some topic, and they have things in the presentation that simply aren't really accurate, right? It's easy to sort of, pick on the researcher and goes, well, you should have done a better job. But really, these things are incredibly complicated, right? Like when I worked at Adobe, I worked on a flash player security model, and it was a full-time job trying to keep that thing in my head at all times, right? Like it was really brutal. So if you're in the business and it's not your job full-time to babysit the security model of flash player or reader or something else, it's really hard to keep this in your head, right? And that's kind of leading, and this is sort of related to the first keynote maybe today actually, is this sort of leading to a gradual shift in leadership in terms of mitigation from researchers to software vendors, right? Because the people that really understand their product well enough and the security model well enough to really try to figure out what to do about a given issue are often not researchers anymore because it's just too damn complicated, right? And by the time you find an exploit and you go do the press stuff and you find out something really cool and you talk about it and then you blog about it, you don't have time. This may not be a bad thing, right? Like if this really frees up the security community to focus on offensive stuff and finding new exploits and attack vectors but cooperate with the vendor trying to solve these problems, it might be actually a really good relationship. So software vendor cooperation and the occasional lack thereof. So this is sort of a pet peeve of mine. I think that when you get a model where every vendor independently tries to solve something like cross-site scripting or clickjacking or CSRF, XSS, whatever, you end up with a really crappy environment. Because what happens is, if you can't deploy as a developer the same mitigation against, say, CSRF, across all different browsers, it's really not useful. It doesn't matter in theory if there's a given mechanism in Safari that works a certain way and IE8 does something different and then Firefox does something different. I mean, who cares, frankly? It's really worthless, right? So I'll give you an example of where, like trying to figure out the security model implications of cross-domain loading in the browser is brutal. I'm going to sort of blow through these. The goal is not to go through great detail and try to do a whole threat model on the fly, but here are the main sort of models you have out there. The Adobe Flash Player cross-domain policy mechanism, both the original version and sort of the updated, stricter version, have Silverlight, you have Java, and you have HTML and a couple different mechanisms within HTML for doing cross-domain loading and information sharing. First one, Flash Player. Flash Player cross-domain policy files, right? You've probably heard about these, the way you can drop a file on a server and says, servers, the service can load data from me. It doesn't govern scripting, by the way, just data loading. So the original version, you can basically put a policy file in the root or a subdirectory. It would dictate access to the root or the entire server or that subdirectory and below. It does send cookies to every request. And there's a new updated version that's much stricter about where you can put policy files and dictating. You can use MIME types. You can basically, the server can specify policies, only support policy files on my server if they come from the following location, or only if they're served with the following MIME type. Or I absolutely will never host a valid policy file, so ignore any policy files you get from me. So Silverlight implemented support for cross-domain loading as well. Of course, they had to do it slightly differently. They created something called client access policy.xml. It must be in the root directory. It can specify which other directories are to be accessed. So you can specify, less than the root. You can specify just a subdirectory or more, multiple ones. You can permit access only from a specific domain or list of domains or from any domain. And you can also specify which headers are allowed to be set and sent. They also implemented support for the Flash player policy file, but unfortunately only in the root, and it forces you to allow access to everybody. Okay. Oh, and it sends cookies. Java supports also the Flash player policy file in the root or a subdirectory, unlike Silverlight. But it does require you to permit access from all domains, and it does apparently send cookies. HTML provides cross-domain resource sharing, CORS, and this is a header-based mechanism. So when you want to make a cross-domain request, it sends this origin header with the origin, the domain that's making the request. It expects an access control allow origin response that specifies yes or no, basically. If it says yes, it echoes the domain that's making that request back to it that was in the origin, or it can specify star, say anybody's allowed to load stuff from me. And it does actually send cookies, except in IE8. And it uses XML HTTP request, except in IE8. Cross-window messaging. This is a mechanism where frames or windows can talk to each other directly. So it's sort of analogous to cross-domain data loading, but it requires actually loading content from there. So sender calls window post message. The receiver has to have an event handler registered for that message type, and can then verify the domain of the sender and look at the message before it decides to do anything with it, right? So it's basically bidirectional or unidirectional, and it's with cookies technically because when you load a frame, you send all the session information for that frame. So what's the problem with this? The problem is that basically, if you can't agree on what you're trying to solve, the basic architectural problem you're trying to solve, then the solutions are not going to be very useful, right? So one simple, fundamental sort of assumption you have to question is an application a domain? Or does an application these days span more than one domain, right? Like if you look at even remotely complex websites, unless you're a very simple thing, you're probably going to have more than one host in your application. And so if you start with the basic assumption that your application or an application is something that spans more than one host, then not sending cookies is kind of frustrating because essentially you can't have a user authenticated session that spans more than one host with these cross-domain loading mechanisms, right? So there's sort of the concept of this problem of trying to solve too many problems with any standard, any sort of feature that trying to address all possible use cases, right? But you can have the same problem where it's just too simple and doesn't address most of the common use cases, and then you basically force people to use the really crappy mechanisms they've used before. So another problem that you have out there is users are not security experts, right? Yes. I think this is a good thing because it's not their job. Like, essentially, any security model requires users to be experts is going to fail, right? So if you're asking yourself, like, how sophisticated does the user have to be to understand security in my model? The answer should be not very. And so dialogues would be an example of this. Like we've slowly in Firefox have been very much trying to get away from dialogues, especially modal blocking dialogues, because they just don't work, right? Like this is sort of my simulation of what happens when a user interacts with your typical security mechanism / dialogue. Okay, so I think that accurately reflects what happens when a user is trying to solve a particular task in their life and runs into a security dialogue. Note that he still just ended up walking right out the door, right? So they get trained to essentially avoid security dialogues at all costs. If you hit one, select yes, because then you won't faceplant. So security dialogues are a symptom of a flawed security model, right? And that doesn't imply you can always get rid of them. Like, frankly, there are some places in Firefox we're looking at, like location-based services, where Firefox can use a third-party location service to tell content where the user is with the user's consent. Now, this sucks, right? Like, ideally, every security model never has a dialogue, right? So in this model, though, what do? Like, how do you determine whether or not it's appropriate to share the user's information with web-based content at a given point in time? You really can't, right? So when do you use a dialogue, when do you not use a dialogue? I think a really good place to not use a dialogue is when the choices you're offering to the user is either to be broken or insecure. Like, that choice put before a user is simply frustrating, right? There's no good selection, there's no good choice. With location-based services, I think it's a little different, right? With location-based services, you're actually asking a question the user may be capable of understanding, which is, would you like this web page to know where you are right now, right? And I can kind of posit that a user of average sophistication can figure that out. And so when you're thinking of security dialogues and thinking of what is a good bar, for anybody, has anybody ever had to help their parents with a computer problem? Okay, construct your dialogues for your parents. And then have your phone number there to call you if they don't understand the dialogue. You'll construct much, much better security dialogues. Or hopefully none at all. So change really is accelerating, right? And this is unavoidable. Right? Like this, I've heard a couple times and I think even Dubai, somebody said, well, if we just went back to how web browsers used to be without all this dynamic mashup crap, it'd be great. Okay. No, it wouldn't, because nobody here would want to use that browser. Right? You can build that browser right now. Go build it. Put it out there. Like, take Firefox, strip out a bunch of stuff, ship it to your 5 users. Right? Who cares? But so you have to be realistic, right? When you're developing browser security models, you have to really look at what people actually want to build in the ecosystem you're trying to support. Right? You have to actually build a security model that supports that environment. If you don't, then people will just hack around it in ways that are far worse than whatever you're trying to, prevent in the first place, right? I'm going to have a little security skit here that I think illustrates a pretty typical developer, security person, management interaction in a modern-day software company. I'd like to introduce the cast in this skit. We have Peter, Lois, and Stewie. Let's see if this wants to play today.
Well, men, the Cohort Men's Club is complete. It took 6 weeks and cost $8,000, but it was worth it.
Peter, I wish you'd get rid of this thing. It's an absolute eyesore.
What do you care, Lois? You girls got the clam, we got the Cohort Men's Club. Besides, we're not hurting anybody.
What are you talking about? You ripped a whole chunk of wall out of the house.
What is this? There's something wrong with the house. I don't like change.
So, but there is actually hope, right? Like, it's not all broken, it's not all doom and gloom. And so this talk was inspired by some of the nothing ever changes, but things are actually changing for the better. Right? Despite all the progress standards, progress is actually being made. Like, security is actually being more effectively addressed in complex feature discussions around cross-domain access and loading and downloadable fonts and all this stuff, right? So now it's built into the specs far more than it used to be. If you look at the old HTML specs, there's no mention of security for any practical use for the most part. What would help is really a broad agreement on the philosophies and goals behind a particular feature, right? So like the first thing you should do when you're talking about feature X, whether it's 3D graphics or whether it's cross-domain loading or downloadable fonts or other potentially neat but potentially really scary things, is what are you trying to solve? Right? What problems, what applications, what are you trying to do? If you can actually do that, if you actually get people to agree on what you're trying to solve in the first place or enable in the first place, then you can have a meaningful discussion about it. If you can't agree on that, then you go nowhere. Trust me, because what happens is people arguing against sending things over here because it's really dangerous, but then if you don't send that thing here, then you can't actually build the app that people want to build. You have to synchronize your assumptions and your goals before you even start talking about the feature. So yeah, maybe enumerate what sort of application architectures have to be covered. You know, like the example of trying to standardize cross-domain loading mechanisms, there's an endless debate in access control / cores about whether or not to send cookies, right? And finally, like, you simply had to ask yourself a simple question. Do you believe that a very common application architecture is that you will have to share user-specific information among hosts in your application? If the answer is yes, you need to send cookies. If the answer is no, you don't need to send cookies. If you don't agree on that, then the rest of the conversation is really kind of pointless. But nevertheless, things are actually happening. We have JSON parse, and I'll talk through these: content security policy, strict transport security, and origin for CSRF mitigation. So JSON.parse is native decoding and encoding of strict JSON strings. It's faster, it's more secure. It's not a replacement of script source equals because it doesn't do it cross-domain, right? So it relies on a secondary cross-domain loading mechanisms to import the JSON blob before it can decode it. So note on JSON, when I say strict JSON, this is what JSON's supposed to be, right? I don't think anybody recognizes this, but it's actually how it's supposed to look. It's not supposed to look like this. Right? I think in here it says it's defining a function. Down there, something about you need to have Flash player, and I don't know the rest because it just keeps going. Like, how are you supposed to reason through the implications of importing this data into your application, right? I'm picking on Google here, but it's not Google. It's like everybody's just, here, download my data, but they just give you a library. They give you an application. You have no idea what you're running at all. This is bad. It's also what happens when the only option you give people to do cross-domain loading is far worse than all the possible things you're discussing replacing it with, right? And that was my biggest argument, is if we don't include cookies in cores, everybody's just going to keep using JSON. Like this JSON, not this JSON. So content security policies I'm going to be working on at Mozilla to address primarily cross-site scripting, but also really just have much better control of what content ends up in your application. A fundamental tenet of this is that data is not code. This is something that browsers don't want to admit. Browsers love just mushing code and data together all day long. They really hate separating it. It's really tedious and just difficult. So content security policy allows you to do a number of things. Allows you to control through a policy, through a declarative mechanism, where you're allowed to load things on a per content basis. It also can basically shut down a bunch of inline JavaScript, like internal script nodes, JavaScript :URIs, event handling, so you can't dynamically set up new event handlers through content. You can disable the ability to generate code from strings using eval, because they're obviously easily tainted, right? So one of the things that came from this discussion originally, the primary goal was cross-site scripting mitigation, right? To do that in a remotely effective fashion, you have to shut down a lot of stuff. You shut down that much stuff, pretty much any framework, any complex application on a given website today kind of breaks, right? So the other thing we did is actually really tried to make sure that we would have an incremental process, right? So you don't have to buy the whole thing. You don't have to go implement the whole thing whole hog. You can implement content security policy on a piecemeal basis and focus first on controlling where content's loaded from, or controlling dynamic script generation and shutting things down in a more sort of atomic fashion. And over time, as you test and build confidence in the model, you can make it more aggressive, right? Turn it up basically. But the goal is so you don't have to sit there and write reams and reams and reams of data sanitization code that then the guy next to you has to write all over again, right? So only explicitly allowed content will load. Policies can be separately defined from many types of content, images, etc. Framing behavior can also be restricted, so it can also address clickjacking, because you can simply have a policy is don't ever frame me, or only frame me from the following domains. And you also have debugging and logging capabilities, so you can specify the ability to log exceptions, right? So if you start having issues on your site, you can figure out why it is that a piece of content maybe isn't working because it's throwing some sort of security exception driven by content security policy. But also, it can actually be a useful attack mechanism, like attack detection mechanism, because you could, in theory, if you know you don't have a val and people are starting to try and inject a val and stuff into your website, you could try to figure out why. You can see that happening. Strict transport security is a spec that was submitted to the WC3C very recently, but being discussed sort of previously. So this is the ability for a website to specify a response header called strict transport security. What that header does is subsequent visits will force the HTTPS scheme to that domain. You have to specify some sort of max age for this policy to be enforced, otherwise it could just be there forever, and then if suddenly you want to revert back to non-HTTPS for whatever reason, you can't, right? So you always have to specify some maximum age. And you can optionally choose to include subdomains, right? So like the root domain could specify this policies of always require HTTPS, never cover every host in your domain, or could cover only that particular host that served that policy. This is from sites such as PayPal that just really want to all be HTTPS all the time. And now they can without having to write lots of crazy code on the server side. Another feature that's being discussed is origin, right? So origin for cross-site request forgery. So it sort of came from a bunch of discussion from Adam Barth and Colin Jackson about extending, originally really, and this may actually may end up what happens, but extending the origin header as used in access control cores to be essentially kind of a better referrer, right? Refer has issues, it leaks URL fragments, and also the biggest problem, it just gets sent on every stupid little like anchor tag click, so you're always leaking origin information about it, and there's privacy concerns, so desktop proxies will filter them out, some corporate proxies also filter out refer, and so it's not a very reliable mechanism for CSRF mitigation. So what origin would do is it would send just the domain, just the host, essentially, but not for everything, right? It would not send it for anchor, window navigation, images, style sheets. The reason is that those generally should not be considered event state-changing operations, so then you should simply deny them, right? So the model with origin simply is if you implement it and you have agent support, which is the browser you're interacting with at the time, supports origin, your model can be really simple. It's like, basically heuristic is the page in question a state-changing operation page, right? Is something useful and scary happening on that page? If it is, and the agent supports origin, is the origin one of the origins I expect? If no origin is provided or it's null, then reject the request. Without having to worry about tokens, a bunch of crazy stuff, right? So there's questions about, because origin right now is only sent with CORS requests or access control requests, it's not clear that we want to use the same header name, because if we do, if websites are now relying on the presence of origin to indicate that it's a cross-domain request, they may get very confused, frankly, right? But it would be nice to reuse it, because it wouldn't have to have yet another header that we're putting into the browser that people have to deal with and sucks up bandwidth constantly. But this is actually a very useful CRS of mitigation. If the agent supports it, it really saves you a lot of work. Other things that have sort of been anti-features, I call them, because they're always anti-something, right? IE supported or implemented X-frame options. My problem with this, it's great, but once again, it's overly simplistic in my opinion, right? So it does support anti-clickjacking, but it assumes that essentially you would only ever want to be framed, or your state-changing pages would only ever want to be framed by another page in the same domain. It's just not true, right? It simply isn't true. Like, unfortunately, in my personal experience, I have two banking relationships where they use this all the time. They have like a third-party bill pay system or some other content they frame from a different domain, right? And that's the sort of stuff I really care about clickjacking, right? But this feature would be useful because it sort of assumes that either they're in the same domain, they're okay, or they absolutely can't be okay. IE8 also has an anti-XSS filter that looks for reflected cross-site scripting attacks. It looks something in the URL that then shows up in the content. It's pretty useful. And then most browsers have implemented anti-phishing, and they've implemented anti-malware, right? So that's all good stuff. So the question for this audience is probably like, well, what to do? Like, what are we supposed to do about this? It's great that all this stuff is going in there. Where does the security community participate in this? Well, just, participate. I mean, peer reviews of security models, right? All the stuff that's going through standardization, it's all there. Take a look at it. Contribute feedback. Get on the mailing list, discuss it. I mean, there's really a wealth of potential contributions that could be provided by the people in this room, but unfortunately that, like right now there's sort of this big disconnect between the standards bodies and the security community. Mozilla has its own Mozilla Dev Security Usenet group that is used for random security discussions. You can subscribe, it's pretty low volume, but there's an interesting security feature we're working on. We'll generally cross-post that list and you'll be made aware of it and you can participate. Download and test stuff, right? We have a tri-server build of content security policy. You can go, and I do have at the end of this I have references. You can go look at a bunch of links at the end of the presentation. But you can go download a Firefox build of content security policy in there and implement it on your website and see what works. Test it, break it. See if your website breaks, see if CSP breaks first. Don't think it'll break, I'm sure. It always does. There's also a strict transport security add-on you can get for Firefox. And all this will be eventually in the code, but we often use add-ons and non-standard builds to test things, right? So we've prototyped STS in an add-on. You can download it. It's called Force TLS because that was the original name of that proposal and got renamed. But if you just go to addons.mozilla.org, you can download it and implement it on your website and test it. See if you can find a way around it. That'd be great. So what can software vendors do? Big problem is they could behave a little better sometimes, right? There's still way too much history of gag orders and sketchy stuff where companies go after researchers for trying to do their job. Vendors sit on vulnerabilities forever, don't fix them as quickly as they should. So vendors should instead embrace researchers and support them. Mozilla, for example, has a security bounty program, right? So if you submit a security bug to Mozilla and it's a real issue and we fix it, we'll give you a t-shirt and a little bit of money. I don't know why everybody isn't doing that, frankly. I mean, they should be. But researchers can do some things a little better too, right? So, I mean, really practice responsible disclosure. It does make a difference. I mean, so we have this sort of very open culture at Mozilla, honestly. I mean, people sort of say that, but until you've worked there, after having worked at different organizations, it's kind of a bit of a culture shock, right? So at Mozilla, I personally have to justify why I want to keep some information closed, right? Like I don't have to justify keeping things open, making things open, just to keep it closed. So why would we keep anything closed? Well, we'll keep things closed that could sort of represent direct risk and harm to our users, right? I really don't want to go discuss a vulnerability that we know about that we haven't yet fixed if it's not public, because there's little benefit but a lot of risk, right? So, I mean, it would go ways for researchers to consider the positions the software companies are in, right? And if maybe they're just being evil and trying to protect their assets, or maybe they're actually trying to protect user privacy and security as well. That assumes, of course, that they're actually behaving responsibly in the first place, right? This has kind of been a pet peeve of mine a couple times. Is it's called security research. Make sure you're actually presenting research, not assumptions. A couple times I've come across issues with people's presentation. I've gone after the fact, up to them and talked to them and say, hey, why did you say this? Because as far as I know, that's not actually true. And every time the response has been, well, I had assumed, right? It's probably better not to assume. It's probably better to test and verify. And yeah, I don't really want to hear another talk about universal cross-site click jacking something or other, add 5 more hyphens here. I mean, when clickjacking came along, everything that was cross-frame was suddenly clickjacking. It's not. Like, clickjacking is a very specific kind of attack. It doesn't really help to try to spread it around like butter on everything that could possibly be sold as dog food. So what could users do? Well, so educate users, talk to them. And security awareness is a big part of users, but don't expect you can turn them into security experts. It's not their job. They're a task group, and their goal is to solve a problem and move on, right? Not to become hackers. But that, interestingly enough, sort of makes the developer more responsible, and the security researcher more responsible for really pushing them in the right direction, right? Like, so one thing, and I'll give you a couple examples. You see the UI changes in Firefox in the last couple of versions to be more forceful in driving users to make the right decision, not simply present a choice, that is A or B. But you shouldn't take user choice away entirely, right? So like, updates an example. Updates in theory, it'd be great if everybody sort of updated magically and the new version was running and you couldn't do anything about it. In theory, until you break somebody's application, until you break somebody's workflow in their company, until you, in the middle of trying to organize a wedding, you break their magic wedding planning application, the bride freaks out and kills everybody, right? So, like, it's great to assume, but you also want to give the user an opt-out if you're wrong. So I have this video again. I think this video is great. I actually really wish that users were as cooperative, as willing as these folks are just to get home. Like, this is how security should work, in my opinion. But it all worked out in the end, right? Like, should we all be this lucky to have users like that? That's all I gotta say. So, here's a change that happened in Firefox 3.0. And this dialog is slightly updated for 3.5, but basically the gist of it's the same. Like, you probably, all of you remember the old SSL dialogues that was like, this website apparently might be really broken and try to rob you. Would you like to continue, yes or no? Well, I don't know. You hit no and the website doesn't work. You come back, reload, hit yes, and the website works. Okay, well, yes is obviously the right answer because the website works. Now we have a slightly different dialog that says, this website is broken, you should go do something else. And in the bottom there's a little like, well, I understand the risks. Oh, if you say so, okay, yeah, knock yourself out. This was very controversial when this came out. A lot of ire from, of course, the more technically savvy people, some of them apparently in security, but not really, complaining that it wasn't our right to once again dumb down the dialogue and take user choice away, right? Sorry. And the argument is, well, sometimes I really just need encryption, I don't care about authentication. Which, on the web, is not actually possible, because the definition of man in the middle is you don't know who you're talking to. So having an encryption channel to the man in the middle, not very useful, right? So in some respects, even pretty sophisticated users can be really, really wrong. But you still need to give them an out, right? If they determine, like if I'm setting up my home router, this is what I'm going to get. Right, they're not going to have a CA, certificate that's tied to 192.1.1.1. So, so this is the lower one is actually the EV certificate UI change was introduced in Firefox 3.0, and the upper one was introduced in 3.5. That was originally supposed to be in 3.0, but it got derailed by a whole bunch of internals sort of arguing, squabbling over "don't mess with my Chrome," right? And the argument was that, well, this information. So what happens is in a DB certificate, we take the host name. Actually, the domain, I should say, the option you configure to be the host and domain. And for SSL sessions, we put that in blue, right? And then for EV, we actually put in, instead of the domain, we put in the organization name, because the whole point of EV is actually maybe you have some slight degree of confidence about who you're talking to, unlike DV. And it was incredibly controversial. People were like, well, don't you mess with my UI, it's redundant, it's not interesting, you're cluttering it up. But it actually is very useful, because for a lot of like phishing and URL spoofing, that's actually very useful, right? Asking a user to parse a URL for security information is a really bad idea. Like nobody knows how to do that. And there's been actually a bunch of interesting attacks where you have a really long host name and weird character spoofing that makes it look like you're really terminating the domain here, but it's actually out here. So these mechanisms are useful, and actually, hopefully over time, users will learn to rely on them, right, and become a source of familiarity. So if it's lacking, the user's a little alarmed. But the problem with all these dialogues, like padlocks and stuff, is nobody ever detects the absence of them, right? You've seen these images where, like if you can go to your bank and you can set up like my favorite image thing, and when you log in, you're supposed to see that image. And people have done studies where all you do is simply don't show that image and nobody notices the image isn't there. So hopefully this is useful, but this is certainly no panacea. So software developers, what can developers do? Change how you think about security. Security is a characteristic of the product. It's not a gate to get through. It's not like you get the security rubber stamp at some point in the release cycle and you're happy. You should be thinking about security through the whole life cycle of the product. And I've seen this evolution in companies that start with incident response. Oh crap, we got hacked. It happens usually like a couple times. They're like, okay, we do get pen testing and we get people to come and hack our infrastructure and find the issues, right? Well, I mean, that's okay, but then the problem you find is that they're almost always like, especially for software, they're finding your stuff way too late in the life cycle. You bring them in usually, before you're going to ship. If they find a serious problem like an architectural issue in your application, not a good time to be rebuilding it. Not a good time to be architecting major features a month before you're trying to like ship the thing. So you start doing security reviews, like, well, when you're about to, like a little sooner, before we actually start testing it, let's talk through what you're doing. And that leads to like design reviews where before you even start specifying, before you even start coding the thing, you actually sit down and agree what it is you're trying to do and why you're trying to do it and what the security characteristics of the feature should be, so it's included in the design, in the spec, before you start doing any of the work. And eventually what happens is you do it in your requirements, right? And when you think about a feature and the user goes, I really want X, you go, well, do you really want X or do you want this safer version of X, right? You should be thinking through security through the whole life cycle of your product, not as this thing you're supposed to just sort of survive towards the end of the release cycle. So I've worked on a couple of security models. I worked on the FlashBlade security model. I worked on really designing the Adobe Air security model and worked on Mozilla and stuff. And so when we look at new features, you have to really consider the implications of the security model. This means is that really iterating security models is incredibly painful. Like this whole sort of like, let's ship it now and figure out later. Taking privilege away is almost impossible. So if you're looking at designing a security model and you have a couple options, one is to be more restrictive initially and target a core set of uses and applications, or you can be sort of more open, which is always very tempting because, hey, if you're more open, you just allow more things, more people will use your application, everyone will be happy, it'll be great. The reality is, whatever you pick now, you will never be more restrictive than that, realistically. Because every time you do, you break people's applications, you break people's websites, and they're not going to like you. And so the cost to do that, the barrier for taking away privilege in your security model further down the road is so high, it's not impossible, but you have to be willing to break your customers. That's not easy. Having done that a couple times, not fun. So, just start with the minimum privilege, and this is why requirements gathering becomes really important. If you don't really understand what people are trying to do with your product, what goals you're trying to achieve, what problems you're trying to solve, you cannot even have this conversation. Not in a functional way, because what's going to happen is like, well, people want to do this and this and this and this and this. Well, we need all this privilege to do it. They just need everything. So that's what they get. So you do have to thread this sort of needle of not too much and not too little privilege, right? So Occam's razor is often sort of misquoted as being the simplest solution is best. It's actually not true. Out of all equally effective solutions, the simplest is best, which is a very, very different thing, right? Simplest simply implies that you're trying to go for the simplest solution, which might be simple, has no bearing on the effectiveness of the solution, right? So security is also not something you can solve. You just don't like, I've had this conversation, people want to solve security. It's like, no, you can't. What you can do is try to factor in security into the cost of ownership. So when you're looking at designing a feature or a product, you have to budget it in, right? And I had these battle countless times where People are like, well, I don't want a budget to have a security release a quarter. Well, we need to, right? I don't want a budget to support an update mechanism that can update all of our users within less than a week. Well, if you want all those users, you need to, right? You should be lucky to have that problem. So, quiz, anybody? Anybody want a t-shirt? Nobody wants a t-shirt? It's really pretty. Everybody will look like just like this tomorrow morning, I promise. No! But close. Nope. Java. You call Java. Close. Silverlight is close but Silverlight doesn't actually place the policy in a subdirectory. Silverlight lets you specify a directory in the policy file. Yeah, but my point is, after a presentation like this, I'm not saying it's a great presentation, but nobody can keep this stuff straight. That's how complex this model is, right? Like I have to go, when I'm doing this, I have to go back, like, okay, which one was the one that crossed the rate, but it sends cookies, but no, you can't. Policy file in a subdirectory, yeah, okay. Like, it's just ridiculous. So a big goal for the web browsers is they need to really bite the bullet and put in the extra effort to try to synchronize these models so the developer is not ripping their hair out. Like, you cannot blame the developers in this environment for having cross-site scripting and CRF bugs everywhere, where basically right now the model's like, here's a grenade, the pin's over there somewhere, good luck. Questions? You want to be the green guy, by the way, in security. If you're not making people uncomfortable, you're doing something wrong. Yep. So the question is, do we have statistics on click-through rates on the SL dialog? And unfortunately, we don't, but that's a really good thing to have. But judging by the people that complained about it, I'm guessing it was probably a pretty big behavioral change. Any other questions? Cool. Yep. Well, thank you.